Welcome back to the final part of the block breaker tutorial. Now, so far we've had parts 1 and 2, and if I just run our program here, we can see the main menu with the play button. We have our page with paddle and blocks, but we don't have a ball really, which is kind of the key point of this game. And I've left this as a whole part to itself because the ball is quite complicated. We need to be able to collide with three things: the boundary of the world, the paddle itself, and the blocks. So first of all, let's actually create a ball. So we're going to go into scene 2, and before we do anything else, actually we're going to select the background, go to sprites, and set the layer on 10. I forgot to do this in the last part. Just as we said before, we do not want the background to be on the same layer as the paddle or the tiles, as it will be re-rendered every time one of those moves, which is not very efficient. So anyway, we need to create our ball. So we click New Scene Object, and this gives us a square by default. So what we need to do in sprites here, we have the image name, procedural square, or I should say the image type. Wade has some built-in types, and one of them is procedural circle. Excellent. I'm just going to zoom in a little bit, and I'm going to move this down so we can compare it to the size of the paddle, just for reference. So I'm going to try 16 by 16. Actually, I think that's big enough. Maybe slightly too small. No, I think that's good. I think that'll do. Okay, so I'm just going to save this, and I'll go to properties, and I'll call this ball. I'm going to set the X position to 0, and the initial Y position to, no, let's have it higher than that. Actually, I think we want it quite a lot higher. Let's put it at 100 on the Y-axis. Okay, so if I play this now, ooh, that's interesting behavior. Let me try that again, see if I can replicate it. I think I may have introduced a small bug. Let's have a look. Actually, I think I know what I'm doing. This has happened since we moved the background. I have a feeling we're not clearing the screen when we load the scene. Okay. So I'm going to go back into the folder, back to scene 1, and I'm going to click on play. And if you remember, we added our event handler in here, and the first thing I'm going to do is once load scene is, actually before load scene, I'm sorry, Wade clear scene. So I'm just ruling out that this is the cause of this particular bug. I think it is. It seems like it would be. So we go back, we click play, and indeed that was the cause of our bug. We were not clearing the scene, so we fixed that, and we have the ball being rendered correctly. Now at the moment the ball doesn't move, so it's not very interesting, and before it can collide with anything it needs movement, so we're just going to go ahead and add some movement to it. Now this can be done in the ball's onAddToScene function, which we are conveniently in. If you are not there by default, you can just click on functions and find onAddToScene. It should be the top one. So first we need to set the velocity of the ball. And I'm actually going to put a property in here. I'm going to go to properties, custom properties. I'm going to add, and I'm going to call it velocity. Actually no, we'll just call it speed. It's a magnitude in this case. And we'll set it to 100 to start with. I have no idea if this value is right. We'll just see how it goes. So anyway, we go back to functions, onAddToScene. We need to set the initial velocity of the ball, which we are going to base off the speed. But we want the direction to be somewhat random. It's going to go at a 45-degree angle, but it could go to the top left, the top right, the bottom right, or the bottom left. So I'm going to create a velocity variable. And this is actually going to be an object, so we get our object. Now it's going to have two properties, x and y, as it's a simple vector. We're going to do math random. Now by default, math random generates a value between 0 and 1. So I'm going to say if that value is less than 0.5, I think that's roughly halfway, then I want the x velocity to be our speed. However, if it is less than that, I want it to be minus our speed. So basically, on the x-axis, this means if the random number is smaller than a half, we'll be going positive x direction, else we will be going minus x. So we're just going to do the same thing for y. y.mathRandom. You can copy and paste this if you want, it's almost the same. In fact, I think it's exactly the same. Yes, it is. We just do that again. And we close our object, which has now ended up on this line. I'll just bring it back here. Excellent. Now we need to set the velocity. I'm just removing these spaces. There we go. So we can do this dot set velocity, and velocity takes a vector quite nicely. We just do velocity. And I believe that might be all we have to do there to make the ball move. So we'll just try running our program. Click play. Ah, the ball does not move. It looks like we have another silly bug. So I'm just going to check. Yes, it does take a velocity of x and y. Oh, that's it. We need this dot speed because speed is a property of the ball. That's all I forgot. And because it was an undefined property, it caused other problems, which is why the blocks didn't render. So we'll just try this again. Click play. And yes, we have a moving ball. Now it moves straight off screen and it's moving a bit slowly. So that's why we have this variable. We can just change it here. Pardon me. And if we need to change the speed, we don't need to have to go into our code and manually change numbers here. It will just all work. So we'll run this again. Click play. And it works, but again, it just goes off the screen. So what do we need to do here? Well, this is really the most complicated part of the program, but don't worry, we're going to take it slowly. We need to go to the ball, and we need to go to its onUpdate function, which is right at the bottom for me. Now, this function is very complicated, and there's three main parts. As I said before, collide with the game boundaries, collide with the paddle, and collide with the tiles. Now these are all slightly different problems because different things need to happen as a result. And the first one we are going to tackle is collision with the boundaries. Now this requires a few properties. So first of all, bar collision equals false. So to start with, we have no collision. And instead of doing lots of function calls, because we need to do maths, I'm going to get some properties right away. So I want the position of the ball, which is just going to be this dot get position. That returns a vector. I want the size of the ball, which is going to be this dot get sprite dot get size. I want half the screen width, so I'll just call this half width equals Wade dot get screen width over 2, and similarly I want half the height. So half height equals Wade.get screen height over 2. This is just because in the next part I'm going to be using these values a lot, and it's way more efficient to store them as a variable, and it looks neater in code rather than calling the functions a huge number of times. So actually I'm going to put a comment at the top of this because again this is going to get a little bit complicated. I want to make it very clear what the code does. So here we are going to handle collision with boundaries. Very nice. So the first two boundaries are simple. It's the left boundary and the right boundary. So all we are going to do is if the position of our ball, the x position, if position x, dot x, minus the size, because of course we want the edge of the sprite, this position is in the center, so we need to minus the size off this. Position minus size.x. If that is less than half of the screen width, and we need to put a minus in here because the screen width is positive by default, then we know our ball is touching the left border of the screen. Conversely, if position.x plus size x of the ball is greater than positive half width, then the ball is impacting the right boundary. Now we can handle this in the same piece of code because we need to do the same thing in both cases. all we need to do is do this dot set velocity, and here is the interesting bit. We simply need to flip the x velocity. That's all we need to do. So we just do this dot get velocity dot x, and we set that to times by -1. That is all we need to do, and then we just keep the current y velocity. Now remember, before we were setting a velocity. Velocity is a vector, so this needs to be an object with an x parameter and a y parameter shortly after. And we close the object. So that should cover our left and right. I don't know if we'll get to see it, but we'll try. So let's run the program. Yes, the ball did indeed bounce, and I noticed something else curious there. The ball went behind the blocks. That's not really a problem because in the game it will impact them, but thinking about it, the blocks should probably be on their own layer too, just so they don't have to be re-rendered whenever the ball or the paddle moves. The ball and the paddle can be on the same layer. I don't think that's a problem. So I selected the block and I've moved the layer to 5. That's just in sprites in case you can't find it. So now we have a ball that will bounce off the left and right of the screen. As we see there, fantastic. Unfortunately, it will still go off the bottom and top of the screen. So let's handle the simpler case first. Let's handle the top. I'll just select the ball. We go back into functions and back into onUpdate. There we go. So this detects collision with left and right. I'm just going to write a comment. This is going to be the top of the screen. So we do just the same thing again. If position.y this time, will it be minus size? It might be minus or plus, I'm not sure. We'll see what it looks like. Minus size y. So if we are less than minus half height, then we've collided with the top of the screen. We're not going to handle the bottom here because the bottom is a slightly different case. Although, thinking about it, would it be more efficient? I think it might actually be. Okay, I'll tell you what, we'll handle the bottom as well here. And bottom. It just means we're going to have to do one check twice, but it saves us some space in the code. So like before, or position y plus size.y is greater than half height. So if we end up in here, we know we've hit the top or the bottom of the screen. So likewise, in fact, we'll just copy and paste it. We need to set the velocity. So I've just pasted this here. Now this is different. We don't want to flip the x velocity. We want to flip the y velocity. So we move our times by -1 there. However, we need to know if it's the top or the bottom, because if the ball has gone off the bottom of the screen, it actually means we've lost. We've missed it with our paddle. And normally you would have a lives counter, something like that, but again, we're adding more complexity. So simply, if the ball goes off the bottom of the screen in this game, we are going to reload scene 1. So we're just going to do a simple check. If this is true, so we have to do it again, which is rather annoying. There are ways around this, but I think this is just the neatest way to code it, and it's quite short. So if we're off the bottom of the screen, game over, we want to do wait.clearScene. And then we need to reload scene1.wsc. Now again, we can just copy and paste our function from app.js, which is here. And hopefully that should go back to the main menu. So let's just save. And let's test this a few times. I want to see the ball bounce off the top as well, so I might have to run it once or twice. Play. Yep, we instantly go back to scene 1. This time the ball goes up, bounces off the top, and as you can see, it's working quite nicely there. It's bouncing off the very edge. And when it gets to the bottom, we lose. We briefly see the Wade loading bar. Of course, you could get rid of that. Now, so that is the first part of our collision handled. The next part involves colliding with the paddle. Now, as some of you may have known, the paddle is a rectangle. and the tiles that we want to collide with are also rectangles. So really it wouldn't make sense to write two different sets of collision code just for this. So what we want to do is write one set of collision code that handles both cases. Now the algorithm for this that I've developed is a little bit complicated, so we're just going to go over it slowly. I'll explain as I'm writing the lines what each line does, and after it I'll kind of give you an overarching explanation as to how it works. So, collision with tiles and paddle. So the first thing we need to do is get a list of all the scene objects that we could be colliding with. Luckily, Wade provides a nice function for us to do this. This.get overlapping objects. And we need a true in there because we may not be on the same layer. In fact, we're not. As you remember before, I separated layers for rendering purposes, which will make the collisions slightly slower in the detection, but we really don't have many objects on our other layers, so we don't need to worry about that too much. So we need to create a for loop to iterate over this list. So obviously if we're not colliding with any, this code will not get executed, which makes sense. I++, close that off, and surround it with curly braces. Now then, all we need to do here is write a little if statement, and this is just a quick check to make sure that what we have is either a paddle or a tile. Oh, in fact, sorry, not, I got a little bit confused there. No, I'll write the code first and I'll explain it to you. So recti.is paddle rects I dot is block. Capital L there. Okay, so what this does is if the colliding object is not a paddle and it is not a block, we don't run the collision code. It doesn't make sense. So we just continue through the loop. Very, very straightforward. Now, of course, if we get past this continue statement, it means we do have either the paddle or a block. And of course, we want to be able to collide with both of those. Now, this requires a little bit of an algorithm, and we've got some other properties. We got them before. We got the position. That's the position of our ball. And we got the size of the sprite of the ball. We also need a few others. So I'm going to start off with the velocity. So we just do this, dot get velocity. Capital letters, I'm holding down shift too long. We also need some other data. As I said, we have position and size up top. Now we need a number, positive or negative, based on which direction we're going, and this is for later on, you will see. So x-axis equals velocity dot x greater than 0, and what this does is if the velocity is greater than 0, it returns -1. If not, it returns +1, and I'm going to use that in a later step. Like I said, I've planned this algorithm out a little bit beforehand because it's quite a difficult one to figure out on the fly. You'd have to mess around a lot, tweak it, make sure it works, and really that doesn't make for that interesting a tutorial, so it's much clearer if I go away, get it right, and then make it for you here. Now, of course, we still may have some teething problems with it, but we'll see once it's working. Okay, so the next thing we need to work out is sort of the overlap that we get. So if you put two objects next to each other and they overlap by a few pixels, we need to know what that's going to be, the amount of pixels. So I need this value. So we take the size of the ball and divide it by 2. So I have half the ball's width. Then we need to get our block, or sorry, it's a rect, isn't it? So rects I dot get sprite, so we're getting the sprite that we need. Oh, I've just realized I've got some S's mixed up here. This should be get overlapping objects, and I've only called it rects, so I'm just going to make it consistent. We're going to have an S on the end everywhere. Yes, that makes sense, and that is get overlapping objects with an S. Sorry about that. So anyway, we get the sprite, we get the size of the sprite, and we do .x over 2. So in effect, this gives us a number which is half the size of the ball in the x direction plus half the size of the block in the x direction. Now this will become useful because we can then use this to calculate how much they are overlapping, the two objects, on the separate axes. So I'm just going to go ahead, I'm going to copy and paste this, but we're going to change the values. So we're going to change this to y, and also I've called this rax. I meant to call it rad for radius, which is not technically the correct term, but it's close. And we need to change size to .y and size to .y. Now we need to figure out the overlap on both axes using this value. So we can do var x overlap, and I'm going to do this in two stages. We will do rects I dot get position minus pos dot x. So we're taking away the position of the colliding object from the ball's x position. So this will give us how close they are on the x-axis. We can then compare that to the difference on the x-axis, the overlap, and we can see which direction it collided from. Of course, it doesn't look very clear. I'm going to explain it, as I said, a bit better after. So it's quite hard to do this. So I just need to go and put .x here, .y. I'm using copy and paste a lot, I apologize. Just make sure you get the x's and y's on the right one. So basically we're calculating these properties for each axis. Okay. Now we've got this far, we can actually finally calculate the overlap. So I'll do this one a bit slowly. So we take our x overlap that we've calculated thus far, and if it is greater than 0, we need to get the x radius, that is the size between the two objects, if they were right next to each other, like just touching, this is the size it would be. We need to take away the overlap, x overlap, and if it is less than less than 0, we do x rad minus x overlap times -1. Now I know this looks like just a load of maths, which it basically is. Unfortunately, collision is one of the harder things you can do. It's not the most simple, which is why I went and figured most of this out beforehand, because if I did it straight away, I would probably make a lot of mistakes and there'd just be a lot of misunderstanding. It'd be very, very hard to figure out what was actually going on. So anyway, we've got this ridiculous list almost of properties. I mean, look at that, it's quite complicated. But all you need to know is this is the overlap between the two objects. So if it's overlapping by 2 pixels on the x-axis, say, in fact, I'll make it clearer, I'll show you. So I click off the ball, I'm just going to temporarily add 2 new scene objects, but I will remove them, it's just for explanation. So we have 2 blocks, the green and the blue. If they are overlapping on the x like this, I mean, we can see they're only overlapping by a few pixels, maybe 2 or 3 pixels. Okay. If they're overlapping on the top, we know, okay, this is only overlapping by 1 or 2 pixels on the y-axis. Now, why does this matter? Well, we need to know which side of our object the ball has collided with. So pretend this square is the ball. If it's colliding like this, I mean, we can obviously see it's hitting the right-hand side, but we need a way to work that out mathematically. Now, notice when it hits from the right, we only overlap a little bit on the x before a collision will be detected and we need to bounce off. But on the y-axis, look how deep into the rectangle we are. We are completely inside it almost, so there's a huge amount of overlap. And because of this difference, we can determine which side we've impacted the square from, or the rectangle. So I'm just going to go back to onUpdate in ball, and I'm just going to save this because it's getting a little bit complicated, and I just thought that explanation was needed. So as I said, we need to work out the side, and that's what this variable is for. So var side, if the x overlap is less than the y overlap, as we just demonstrated before, we must have hit the side of the block. And if we've hit the side of the block, in fact, I'll just write a comment there for you, hit side of the block. If we've hit the side, we need to do what we did when our ball was hitting the boundary earlier. We need to simply flip the x-axis. So we do this, dot set velocity, and because we've already got some of the values, we can actually do it a bit more simply. So we set our x to the current x velocity, times by -1, and we set our y to velocity dot y. That should be fairly straightforward. Now really, we don't have to do this, but I'm also going to correct the position. I did not do this with the boundaries. When the collision is detected, we may not be on the very edge of the object. We may, as I said, already be partly inside it. So as well as reversing the velocity, we also actually need to nudge the object slightly, and that is another reason we calculated the overlap. So we can move our object by the overlap so that the two are no longer colliding. So to do that, we do this dot set, position, not velocity here. And we just do position dot x plus x axis times x overlap. Excellent. And that's pretty straightforward there, nothing confusing. And we also need the y position, which is just going to be the same. It is just going to be pos y. Now, of course, there is the other case. If we are not hitting the side of the block, we must be hitting the top or the bottom. So we go and write our else statement, and we handle this case. Now, it's very similar. In fact, it's so similar, I'm going to copy and paste this code, as I often do. It often gets me into trouble, but it does save time. And all we need to do is move our multiply by -1 to here. And this one's actually a bit more complicated. We need to remove all this and put it on our y. But instead of that, we need plus the y-axis, and we need to times it by our y overlap. So that's pretty straightforward. It should result in a collision. I say should because things never usually work out the way you want in programming. You have to trial and error a bit. So I'll just quickly correct a little bit I've missed off here. I'm just going to write down the actual side. It might come in handy later on. So there we go. And I'll just do the same here. So what I'm saying is, if y-axis is greater than 0, then we've hit the bottom, else we've hit the top. And I've used this a lot in this program. You'll see all these question marks and colons. This is basically if this condition is true, do this, else do this section. So it's pretty simple really. And one last bit we need to consider is if rects I dot is ball, and remember we flagged, ball, I keep making that mistake, block. We flagged our blocks earlier with is block true. So when we collide, we know if it's a block, and if it is, we can remove it from the scene. Wait.remove scene object rects I. Now, one final thing, I only want to capture one collision per frame. This is for safety. If you can capture multiple collisions in one frame, you could potentially flip the direction the ball is traveling twice, which could result in some interesting behavior. Also, because we are potentially removing objects from the list we are iterating over, some very nasty things could happen. So basically, we're not going to do that. So I think after writing all this code, it's time to see if it works. And I've got my fingers crossed a bit here. I'm not completely sure. Let's hope. So I play. Yes, it did hit off a block. Will it hit the paddle? No, it went straight through the paddle. Okay, let's try that again. Okay, so first things to check. We need to check this is paddle flag. Because clearly, if I haven't set the paddle flag, then this won't work. So we're going to go back to scene 1. And actually, no, we don't need to be in scene 1. We were in the right place. Scene 2. We click on our paddle. We go to properties, custom properties 1. It doesn't have it, I forgot, I'm sorry. So we append is paddle true as our value. We save, we run, and then we hope it works. That's how all programming works, ladies and gentlemen. Yes, it now bounces off the paddle. Excellent. We have a functioning game. Oh, what did that collide with? I thought I saw it collide in the middle. Oh, that's actually dangerous. I think it's colliding with the template object. Now, it shouldn't actually do that. I'm surprised it did. That might be a bug, but if it is, we'll fix it. But in the short term, to fix that, let's just move the template outside. I saw it bounce off an invisible cube up at the top, and I immediately realized that's what it was. So I'll now run again. So if we miss, the game restarts. If we hit, we get to break the blocks. Now, really, there's lots of things you can do. You can add points every time you break a block and display them. But this tutorial is getting very long. The collision section is actually even longer than I thought it would be. It is quite complicated. So what I'm going to do instead is I'm just going to make it so once all of the blocks are gone, they will respawn. That's all I want to do. So we need to go to where we were creating the blocks. And I believe that is in scene 1. If we click on play, go to functions, on mouse down. Now this is our event handler for when we load scene 2. And this is how we are creating the blocks. Okay, this is all we are doing. What we need to do instead is put this in a function. So we can just do wade.app. And I can call this whatever I want. It's a global function, so it's not really great, but it's not too bad. And I'm just going to do create blocks. Very simple. We put it inside there, and we call it here as well. Just because obviously we actually need to call it once here. And of course this is a good test to make sure it still works and we haven't broken anything. If you ever make a change like this, you should always make sure that your code still runs fine after. So I'm going to run, going to click play, and the blocks still appear, so the function works. Now, of course, because we've separated it into a function, we can call it anywhere we want within reason. So we need to call this when there are no more blocks remaining. Now, that's not amazingly easy to do, but it's not too hard. So we're just going to improvise a little solution here. We're going to go back to scene 2. And basically, every time a block is removed, I think we're going to test how many remain. So we click on the ball. We go back to its onUpdate function, where all our nasty collision code is. I say it's nasty, it's actually quite nice. It's just, it looks a bit intimidating at first, but once you get the hang of it, it all becomes friendly. So, rect is block. We remove a block. At this point, we need to get the scene objects. We need to count how many have blocks. And I actually can't remember the code to do this, so I'm going to have to quickly look at the documentation. So I'm pretty sure there's a function. Let's have a look. What do we have here? And of course, you can always find the documentation at clockworkchili.com, developers documentation. You can just copy the link. It's pretty easy to find. So what have we got? Layers, objects and area. Not quite, but getting closer. Get scene objects. There we go. Property and a value. So I want to use this with isBlock and true. So I'm just going to take this here, copy and paste. I hope it doesn't copy and paste the link. That would be rather annoying. I'm going to go back here and do wade.getSceneObjects where isBlock and true. And all we need to do, in fact, we don't even need to store it. We can just do if this dot length is equal to 0. Actually, I'm going to be really safe. I'm going to be say less than or equal to 0. Then we've won the game. We want to remove the objects. We want to clear the scene. Actually, sorry, we don't want to clear the scene. We just want to either... There's two ways of handling it. We could reload scene 2 from inside itself, but I really don't like that. Or we could use the function we just made. And I'd much rather take that approach. So we'll just go back to scene 1, find the name of the function. It was wade.app.createBlocks. And we're just going to go back to scene 2, save, go to the ball, go to on update. And here we go. We are going to call, in this case, where there are no more blocks left, recreate the blocks. So we get lots of blocks. Hooray. Save. And I think that absolutely should be it. There's only one more possible thing we want to consider. If we create the blocks and the ball was in the middle of the blocks, we might instantly decimate the entire thing. So we should probably be safe and set the ball's position. And I do believe we can just do that with this dot set position 0, 100. We should probably store this initial position somewhere in a property, but I think this will do for now. So anyway, let's run our finished program and have some fun. And really, once you've got something like this working, this is where the fun starts, because of course you can play it, but you can also tweak values and then things get more interesting. Of course, if you tweak the values too much, you might break something, but that's where the fun is. So I'm going to click on the ball. You remember I put a speed property in here, speed 200. Let's put it to 400. Now with our type of collision detection, we'll actually break it if we put the speed too fast, but I think this should work okay. And indeed it does. So hopefully you've enjoyed this tutorial, guys. It's been a bit of a long one, I will admit, but I'm afraid collision is a little bit of a complex subject. But here you are, a nice breakout clone that you can improve, you can add anything you want to it. So hopefully you've had a good time, and see you next time.